Okay, continuing with the ongoing saga of this free response question that we've been working on. Consider the graph of f of x shown, which consists of four straight line segments. So this is crucial here because this is going to tell us something. This is going to tell us something here, right? We go down a little bit and we get some information. It says if h of x is equal to the definite interval of 1 to x of f of t dt, find this. We did this in the last video. We did this on the last video. What are the critical values? So we can talk about those. The critical values, of course, are where h prime at x, which is equal to f of x, is equal to 0. So where are those places? They're here, here, and here, right? Because we know this is a derivative function here, so we know where the slope goes to 0, there's going to be a change, and it does. The slope is 0 here. Look, the slope is 0 here. It goes from a positive slope to a negative slope, right? And the same thing is looking like it's going to happen here. Let's move on to what are the points of inflection of h and justify. This is not bad at all. It just looks like crap. So the first thing we have to ask ourselves is, when does f prime at x equal 0? Well, we know these are all these are all lines, right? So what's the first derivative of this line? Well, it's whatever the slope is, so it's a horizontal line. What's this one? It's a horizontal line. What's this one? A horizontal line. And whatever the slope is, it's the horizontal line, y equals that value, and so forth. So we know that that doesn't exist, right? All the derivatives are horizontal lines. So we need to find where h double prime at x, otherwise known as f prime at x, is undefined. And we can see that at 0 it is, right? Because it's, right, we know these places where derivatives fail to exist. And one of them is oscillating behavior, and one where it takes turns too quickly, like absolute value functions at the point of that it shifts. Because look, this thing is not smooth and well behaved, right? If it was smooth like that, then we'd have something to talk about. Let me do that again. If this change went like this instead, we would say this thing is differentiable here. But look how sharp that turn is right there. So it's not differentiable here. So we say it's undefined at x equals 0. It's undefined here, right? At x equals 2. And it's also undefined at x is equal to 4. So look at what happens here, though. Look at what happens here. Here, let me make sure that I'm answering the question that's being asked. Right, we want these inflection points. So we have a possible inflection point here, don't we? Look here, we're like, what's a possible inflection point? So we have to go and do that test and see, does this change? And this goes from positive slope to positive slope. This is not an inflection point. We go to the next one and test that one and say, okay, here the slope is positive, and it does change. So this is an inflection point. And here, where we have this undefined place, we have an inflection point right here also, because it goes from a negative slope to a positive slope. The sign of the derivative changes, and that's what tells us that we have an inflection point, right? So since f prime at x changes sign at x equals 2 and x equals 4 only, these are the only inflection points. This is not an inflection point because it doesn't change sign, right? Positive slope here to positive slope here. Positive slope here to negative slope here. Negative slope here to positive slope here. The sign of the derivative doesn't change. All right? All right. And, did we talk about the last one? What else did I forget? Let's just kill this whole thing now, shall we? What are the critical values? We didn't do critical values. What are the critical values? The critical values are these, right? The critical values are this one, and this one, right? Okay, you guys, I'm maybe as tired as you are. So hopefully this helped you a little bit. I just want to say, when you get something like this, and you're going to see something like this on that exam, think about this as its pieces. Can you see that this might be its own little function, f of x? And this might be its own little function, g of x. And this line right here might be its own little function, h of x. And this might be, I don't know, j of x, I guess, or something like that, right? So my point is that we have to be able to look at this in this way and start, right? So when you see this, take a deep breath. Don't forget, people see this, man, and they lose their minds. You can do this. I promise you can definitely do this, all right? So if you're not subscribed already, please do. And if you have comments, I'd love to hear them.